Good day, my pre-calculus students. Today we're going to be going into section 10-2, and we're going to do two things. One, we're going to give an introduction to conics, and then we're going to talk about parabolas. The first thing we'll do is, how do you recognize each conic section, and how do you solve problems involving parabolas? Now, when we talk about a conic section, there are four different types of conics. There's the parabola, there's the circle, the ellipse, and the hyperbola. So we're going to be working out those type of conics for the next several sections. To understand what a conic is, we need to go and use our book. Roman numeral 1 deals with conics, which is all shown to us on page 735. And one thing we're going to focus on for the next several sections is the equation for a conic section. And it looks in this form of ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And once again, we're going to have numbers there. We may have all of those values or those terms, or we may not have all of them, but you'll see as we get into the introduction, you'll see which ones use. Now this part right here we won't see until section 10-5. A lot of the problems we're going to deal with now will not have this. This part right here of this equation of a conic deals with rotation of conics, like rotating a parabola or rotating an ellipse or rotating a hyperbola. Can't rotate a circle because a circle is a circle. Now you probably noticed that I've underlined the coefficient of x squared and the coefficient of y squared. These two values, or these two coefficients, really tell you what type of conic you're dealing with. So if you look at the first one, is if either the a is 0 or the c is 0, you got a parabola. In other words, if a is 0, we're not going to have an x squared in our expression, we're just going to have a y squared. In that situation, we're going to have this type of a parabola. This is a type of parabola that goes up or down. Some books or some videos will say fill, spill. It doesn't matter. Now, if the c is 0, okay, you're going to be left with just the x squared expression, and this is what that type of parabola looks like. This is an example of a parabola that goes left or right. I'll show examples of that in a moment. All right, now if a and c, in other words, the coefficient of x squared and the coefficient of y squared, have the same sign, that means if they're both positive or if they're both negative, that's going to be an example of an ellipse. Doesn't matter what the value is of a and c, it's just they have to have the same sign. This has to be a positive, this has to be a positive. This has to be a negative, or this has to be a negative in order for it to be classified as an ellipse. The next conic is if a and c have the same value. So if you, in an equation, you see that a and c are like 4, that is going to be a picture of the conic of a circle. And the last one, if a and c have opposite signs, that's going to be an example of a hyperbola. So in other words, if the x squared here has a negative value and the y squared here has a positive value, that's a hyperbola. If the x squared term has a positive value and the y squared term has a negative value, that's going to be a hyperbola. And then there are two types of those. There's going to be one that's going to be horizontal, and another one's going to be a vertical. I'll go over all that stuff when we get to it. You guys with me? All right, so these guys are really important to know. You got to know the coefficient of x squared and the coefficient of y squared, because once you know what those values are, you'll be able to say, oh, that's a parabola. Now I got to start thinking, how do I set it up in this form? Oh, it's an ellipse. What does that look like? How do I set it up? Etc., etc. I think you guys can get that. All right, the next thing I want to look at is we've already did the introduction. We've already showed you what a conic is. The first thing they look at in the section is if you look at page 736 to 738, they talk about parabolas. Now, I am going to do the examples just like they show in the textbook. And then on my next video, I'm going to show you another way of doing these parabolas or ellipses or whatever. I'm going to show it a different way, okay? Both the ways are going to correct, but since you guys have been studying using your book, since you've been studying in your book, I'm going to go and treat all my examples in this video just like they're showing on page 736 through 738. Now, the beginning part of page 736, they go over the details. So, again, a definition of a parabola. A parabola is a set of all points, x, y, in a plane that are equidistant from a fixed line, which they call the directrix, and a fixed point, which they call the focus, which is not on a line. And the vertex is the midpoint between the focus and the directrix. The axis is the line through the focus and the perpendicular to the directrix. Now, that's all the definition of a parabola. But here, I'm going to show you this picture right here. This is the way I'm going to talk about it in the second video. But again, just if you stop and think of it, this is our parabola. This is an up-down parabola. And if you look at the beginning of the definition, a parabola is a set of all points. Here is, following this curve, this is the set of all points. That's what that means. That are equidistant from a fixed line. So this guy right here, this is your fixed line. They call that the directrix. So in other words, if I were to pick a point on this parabola, this is just by definition, it says if I pick a fixed point, and it is equidistant from the fixed line, so this distance from here all the way down to this directrix or fixed line, and a fixed point which they call the focus. So in other words, what it's saying is if I pick any point along this parabola, the distance from that point to a point on the directrix and the distance from that point to the focus, those distances will be the same. Very important, especially if you want to use the distance formula. All right, now the next part says the vertex is the midpoint between the focus and the directrix. That right there is your vertex. And if we were to apply the definition of the beginning part of the sentence, this distance from here to here, from this point of the vertex to the focus, and this point here to a point on the directrix, that's going to be the same distance. And something else here, this the axis, which is the axis of symmetry, is the line through the focus. So this guy right here is your axis, the axis of symmetry. It goes to the focus and is perpendicular to the directrix. All right, so that deals with the definition of a parabola. Here is a picture of the parabola. I'm going to probably bring him back later because you're going to notice that all these formulas on here are a little bit different than what I'm going to show in a second. Okay, I'll talk about those types on the second video. Like I said, I'm just trying to keep you guys in the same book as me. Okay, I prefer the other way, but we'll talk about that later. All right, now, since we're dealing with nothing but parabolas, all this information still somewhat is on page 736. So we have two different types of parabolas. We have an up-down parabola, and we have a left-right parabola. And the first one here is a up-down parabola. And it will come in this form right here. Another way of doing it will be similar to saying y equals ax squared plus bx plus c. Okay, this is a up-down parabola. So I have some information here. You're more than welcome to pause the video and write this down. Okay. Then the other one, the other form of a parabola is a left-right. This is an example of an equation that will have x equals ay squared plus by plus c. And this is going to be a left-right. So here is your information on that. I'll let you guys go and memorize that, study it. It's all on page 736. Now, the next thing they want to talk about next is another bullet point for Roman numeral 1 is the value of p that comes from the equation. The value of p is the distance from the vertex to the focus. All right, once again, p is the distance from the vertex to the focus. So if we know this right here, that is going to be our value of p. Then another one here is just a special note. They use that on a couple of examples. They use that on page 736. All right, so that is Roman numeral 1. Goes over the definition, talks about the two different types of parabolas, up, down, left, right. So let's see how this works. Again, I'm going to do these examples just like the book does. So let's just do some examples. And then tomorrow we'll do, the next video I'll do a different way. Here is our examples. Let's find the vertex, the focus, and directrix of the parabola given by this quadratic equation. Y equals 1/2 x squared. All right, now what I did next is I took all that information and I set it up into, well, right off the bat, I know this is a y equals, so I already know that this is going to be an up-down. Okay, so what I'm doing next is I'm taking that given information and putting it in this form. That's all I'm doing. That's exactly what the book does. That's what they're going to show you on any other video, that they're going to try to put it in this form. So that's exactly what I did. So again, this is y equals 1/2 x squared. I just rewrote it in the way set up as your book does. That's all I did. I just try to keep it the same way. Okay, multiply both sides by 2, and then I wrote this down into that form. Then on the right hand side, I plugged values into it. Okay, all right, let's move on. Just some information here. We know from the notes 4p has got to be 2. Again, I got that from the problem right here. And if way you look at here, they have, this is 2. So 4p has got to equal 2, so that means p is 1/2. Now, in your brain, you're probably saying, what does that mean? Well, once again, that means from the vertex to the focus, its distance is 1/2. All right, the next thing done here is I just identified everything based upon all those rules. Again, all those rules are found on page 736. I have noted them in the book. Vertex is HK, focus is H, comma, K plus P. Axis symmetry is Y equals K minus P. All that stuff is going to help you when you set it up. So that is pretty much what they're asking you to do in this book. All right, now let's go to number 2. Number 2 is find the vertex, focus, directrix of the parabola given by this equation right here. All right, now, just by the way this one is looking up, this is going to be a up-down parabola. So what we're going to do is, the reason I know it's going to be up-down is because this right here, this venture is going to be y equals. That's an up-down. So the first thing I did is I added a 31 to both sides. I'm trying to keep it in conjunction to what they're showing on page 737 and 738. All right, the next part is something that we have done probably in Algebra 2. We probably introduced a little bit in pre-calculus, is completing the square. So again, you're probably saying, where did this one come from and where did this one come from? Well, if you go here, again, if you got to stop and think, what we're trying to do is we're trying to get our problem in this setup. And if you look at this part right here, that is a factored form of some trinomial. That's what we're trying to get to. And how do you do that is very simple. Take the coefficient of the term x, take half of that. So 2 divided by 2 divided by 2 is 1, and you square that value, which is 1. And you take that value and add it to both sides. Combine like terms on the right side. Then the next thing we do is, I know that this is a trinomial, and it will factor out to x minus 1 squared. In other words, what are the factors of positive 1 whose sum is negative 2? It's got to be negative 1. The right-hand side, I factored out a 16. And if you stop and look, we're at that form right now. We are at this stage of the problem. So just by looking at information, we see that h is 1. Remember, it's x minus h, so h has got to be 1. This is k minus 2. Again, it's not written in that form, so it's why it's negative 2. Then your focus. Again, in order for us to do the focus, we got to know what the value of p is. In other words, that's the distance between the vertex and the focus. So we already know that 4p has got to equal 16. And if we solve for p, we know that p is going to be 4. So doing our math, then we will see that our directrix is y equals negative 6. Now this is the way the book is showing. I'm going to do another example by still using the examples in the book. And then in the second video, I'm going to show it a different way, okay? Same answers, just doing it a different way. All right, now something else we got to do in here is try to find the standard equation of a parabola when they give you small bits and pieces of information. So again, what they're giving you here is they're giving us the vertex and they're giving us a focus. Now we can go and look at these 2 points and look at the y values and say, well, they both have the same y value. So that tells me that this is going to be a certain type of a parabola. Now what I do is I try to go, instead of just doing the analysis, I just go ahead and plot those points. So what I did is I plotted those 2 points. So I see that my vertex is at 3, 2. And I notice that my focus is at 1, 2. Well, going back to the diagram, we know that the axis symmetry goes through those 2 points. So this is going to be an example of a parabola that's going to go left, right. So with that said and done, I have to use this equation or this form to figure out what my equation is. Okay? Now this is the one in the notes where we did at the bottom here. Okay? This is where we have a parabola that goes left or right. So with that said and done, well, we already know, I just wrote down my information, we need 3 things for this equation. We need to know what h and k are, which is your vertex, and you need to know what your value of p is. So we know hk is your vertex. They gave it to us. So h is 3 and k is 2. So we know now that h is 3 and k is 2. You can fill that in. And now we need to find our focus. So our focus now is using this point right here. And what I did is on the side is I know that h plus p has got to equal 1 of the focus. I'm relating that. So this has got to equal this. So again, we know that in this case, we already know h is 3. So 3 plus p equals 1. So p has got to be negative 2. And I know it's left because if you go back here, and since our value of p is less than 0, I know it's going to point to the left. And that is exactly what we're showing here. Another tool here, why I know it goes left besides the math here, is your focus is always on the inside part of your parabola. So there, all you got to do now is just plug your values in. We already know p is -2, so if you go 4 times -2, you get -8. There is your standard equation of the parabola. All right, let's go to the last one. This one is saying they're asking us to find the focus of the parabola given by this particular equation. Now this one's written a little bit different. Okay. Well, I know just by looking at this is going to be up, down, but I know specifically, and since this is a negative sign right here, this parabola is going down. So the next part is just do our math. Okay. Well, again, how did I know all this? Well, we have to go and take all this, which I show it down here. We have to take this information, or that type of equation, and we have to put it up in this form right here. So that is what I am doing in this part right here. I am trying to take this equation and putting it into that form. So first thing I did is I multiplied both sides by 6. Then I added a 2 to both sides. Then here I did completing the square. Take half of 4, which is 2, and I square it. So 2 squared is 4, so I took that value and added it to both sides. I didn't show it here, but 4 plus 2 is 6. Factor the left side and factor the right side, and there's that form. That form right there is, the way I have it written, is flipped. So this is this, and then from here you can identify what h is, what k is, and then to find out what p is, I did that on the side. We know that 4p has got to equal -6. Goes back to this guy right here, and that means p is -3/2. So what I did in this video today is focused on pages 736 through 738. So I'll let you have an opportunity to look at those, go back and restudy it, think it through. And what I'm going to do on the next video is I'm going to do it a different way. I think it's only fair. I like the other way that I'm going to show in video. I'm just trying to show you what they have here in the book. Okay. All right, guys. Catch you later. See you on the next video. Bye.